Yeah, you guys can hear me. If you are not able to hear me, just mention in the chat. You're able to see the, some blank screen or some message, and you should be able to hear my voice. If yes, just send a chat message that yes, you can hear me. So Anjana said yes, clear now. Okay. Vivek has joined. Vikrant. Okay, Manjunath can hear. Vivek can join. Vikrant can also say yes. Mesh is yes. Harmesh is yes. Kiran also can hear. Harmesh Yadav. Okay. Welcome, Harmesh. Okay, you can see and you can hear also Varun. Okay, thanks, Varun. Sheikh, I am not able to hear you, but can see the screen. Okay. So you need to check, Sheikh. I mean, because rest everybody is able to hear. Maybe you can try using another browser. I'm not sure how many will join, but we got huge amount of request, around almost like 50, I guess. So let's see how many people are joining today. Okay, so all of you can see this slide. First slide, it says checkpoint troubleshooting using TCPDUMP. Very nice. Okay, good. Yeah, somebody is asking whether we're trying to record this. Okay, to answer you, read this. Just take 20 seconds or 30 seconds, just go through this briefly. So this is the lab topology which I have created on VMware, and this is where I'm going to demonstrate you all the commands which we will run through TCPDUMP and try to understand from the checkpoint perspective how we can troubleshoot checkpoint issues using the TCPDUMP command. So what I will do is I want you to download this PDF. It's basically a PDF file, the topology diagram. I am sending you the link through chat, okay? And so that whenever I'm doing any exercise, you know what exactly we are trying to capture it, okay? So this is the slide. Let me copy the slide link, send it to everybody. Yes, confirm. Thanks for confirmation, Mitesh. So this is the topology diagram. So basically it's a cluster, it's a single box. I represented a diagram, but basically it's a cluster. ETH0 is your internal, where you have a PC which is working on a LAN, and there is a management server. IP addresses is mentioned, and then there is a the table I have provided where I provided the cluster IP addresses along with the MAC addresses. Why I have provided MAC address, I will let you know later. Then there is an internet link as well. This lab which I am just showing you, everything, if you are a little good in VMware, you should be able to create all by yourself. That's a good part about learning Checkpoint. I mean, you can create your own stuff very easily, and you can work on Checkpoint as if it's a live firewall. You can troubleshoot, you can configure and everything. You don't need any hardware specific or any kind of the dummy kind of software to troubleshoot or start working on Checkpoint. Just go through this diagram so that you understand. If you have any question, you can let me know. So the very first question, why I've selected TCPDUMP. So TCPDUMP is a command, if you are into networking domain, you should be aware of at least this command. You should not be someone who say okay, I never heard about this command. If that is the case, then you have to make sure that you are in the right field, or somebody not have pushed you to work into networking domain. Okay, so why I have selected TCPDUMP for this session demo class? Because it's the most overlooked command. It's a very powerful tool, but many people are not aware of the powerful nature of this command. Mostly people will just type a very basic TCP command just to see some packets, and that's it. But this command can do much more than that. Okay, this is what we are going to learn today. Okay, so Manjunath said ETH3 should be LAN as per the IP address. Yes, let me see. ETH3, no, it should be as per the diagram, yeah, it should be external. Okay, the way we have created in the VMware, I mean, you can ignore this portion because in the real world it could be anything. You just see external, internal, and DMZ. You can just take it in that direction. You should not be going into too much in detail. As per my lab, ETH3 I am considering as external because that's where my data card is connected, and via data card packet is going outside. Okay, that's why I'm calling it as external. So the reason which we were discussing about why TCPDUMP, right? The second most important thing why TCPDUMP is because if you search internet and try to look for the checkpoint troubleshooting classes, in fact, I have not found like anybody considering this command to talk about it, like that you can use TCPDUMP even for the troubleshooting. So that's what based on my experience, I have utilized this command like anything. This is one of the most powerful tool which I have used which I use whenever I'm troubleshooting checkpoint. But generally you will see this TCPDUMP section completely missing from the advanced troubleshooting of checkpoint. Okay. This is highly sophisticated, I've already told you, but this we can see it later on, like as we move ahead in the class today. And the good part about this command is whatever you are going to learn today, you can just replicate exactly the same thing on any Linux command. So if you are good in Linux or you are working on a Linux system, basically you are just helping to troubleshoot two different domains. So if you are working on a server or network side, and if you are working on any device which is Linux based, you can exactly based on my experience, almost all the commands should work on a typical Linux system, like a Red Hat or CentOS, okay, or SUSE Linux. All these commands will work fine. Why again TCPDUMP? Somebody will say, why I'm troubleshooting with TCPDUMP? Why not tracker? Because tracker is the one which can tell me what packets are passing through checkpoint. So if you have worked on checkpoint for longer duration, you will know that checkpoint tracker will suppress the logs. It will not give you each and every packet which is moving in and out of the box. You should not, consider a tracker for, for trouble. I'm not telling that you should never do that, but yeah, it has its own advantage. But TCPDUMP is much more powerful from that perspective. And again, you must be knowing that Gaia operating system is based on Red Hat kernel. So whatever goes for a Linux, it has to go through the Gaia OS as well. So I have around 16 years of experience, and based on my experience, I always recommend or tell anybody TCPDUMP is one command which all of you, if you are into this domain, should know, must know. Okay, it is very, very important. It's almost like must for all. If you are into this domain, you should know what exactly it is. If you are not knowing it, that means you are definitely, you do not know what exactly you are missing. The very first command, the moment we say TCPDUMP, the very first command. So most of you who are already aware of this command or worked on the checkpoint troubleshooting or any Linux, well, this is the very basic command which anybody will type. Correct? Just type TCPDUMP, you give -i, -i, interface name, and just type host and IP address. What this command will do is it will capture each and every packet, whether it is a source or it is a destination, matching the host IP address. Okay, this is a very basic command to capture it. So if I'm running on my Gaia OS, the gateway, I type this command, I get that. Another thing is you can just type TCPDUMP, you don't type anything else, but that's a default command. Never use that, because just typing TCPDUMP will capture each and every packet from all the interfaces without doing the name resolution. So I don't recommend that. So that command I'm not telling you, to start with. The very first command should be with a specific interface and then typing the specific host. So you are troubleshooting checkpoint and you want to see any packet, whether it is reaching the firewall or not, you type this command, TCPDUMP -i, and this is how the packet will be displayed. Okay. Now look, let's go back to the next command. So the problem with the earlier command is, if you look carefully, look here, it automatically resolves the IP address. If it will go back to your DNS and it will ask for what is the domain name for that particular IP address. So running this command is again not very efficient because this command will run little slow. Why? Because it will try to get the domain name of the IP address to display it for you. So basically, if you are troubleshooting it, generally you want to avoid that, and you want to focus completely on IP addresses. To do that, just put -n. Okay, -n if you type, rest of the command is exactly the same. You'll start getting the IP addresses. So instead of the Google domain, you get the exact IP address. Okay, so this is clear. Okay, so next command. So instead of single n, you can type 2 times n. Why? Because if you type 2 times n, it will not resolve the protocol. So if you can look here carefully, this is basically a port number 80. It's a HTTP protocol. So if I don't type, if I just put -n, this will be represented as HTTP. So as we move from one slide to another, these commands will go a little complicated. If a specific command you want me to talk after, like when we reach to the Q&A session, you can just note down the slide number or particular command and you can ask me. We can always come back and discuss on that. Pramod is saying something, sir. N means okay. N means basically name resolution. So you don't want to resolve it to the name. Okay. When you are capturing the packet using the TCP dump, I mean you have to make sure, like especially working with the production firewalls, you cannot just type this command and run this forever, or else you have to be very, very attentive that yes, I am running the command, and then you press Ctrl+C and stop the command. If you don't do that, like it can hamper the performance of your gateway, and you may come up with some kind of surprises which obviously you want to avoid. So what you should do is, generally you should always use -C. C means count, and then you type some number like 50, 100. If it's a very, very basic level of troubleshooting, you just type 2, 3. If you just want to see one single packet, just type 1. Correct? If you can see here, it's -C is 3, right? So I'm capturing 3 packets. Let me highlight it. It's 1 packet, 2nd packet, and the 3rd packet. So 3 packets we have captured. This is how you should be able to do. So you learned what you learned from so far. TCP dump space I for interface. Make sure you type some interface. If you don't want to type any interface, or for some strange reasons you want to capture on all the interfaces, like you have suppose 5 or 6 interfaces on your firewall and you want to capture on all the interfaces at one point of time, instead of interface name you just type any, ANY. That should be good enough. So it will start capturing on all the packets. Okay, so now you have captured so far the particular host, correct? And now I will show you how to capture for a particular port number. So this will be very, very important, because suppose if you are troubleshooting and you want to test only, somebody will say, okay, HTTP is not working, or ping is not working, or telnet or SSH is not working. So you want to capture a particular port, correct? For example, in the slide here, I am trying to capture port 80 here, 443 port number. So I am capturing all the HTTPS packets, and -C 5 means 5 packets I am capturing it. So that should be good enough. Now, so we learned how to capture a packet for a particular host and also for a particular port. And obviously, like you want to club this together. So you want to capture a packet for a particular host, because if you type just the port number, so anybody who is sending HTTPS port will be able to, the data will be displayed for all of them, but you are not interested in that. So you want to specifically filter the logs for a particular host. So you can always combine. So you can just type host IP address, use the word ANDN, and then the port number. So remember, host means any IP address. It could be in source or it could be in destination. Okay. So it could be on this side, this is a source, or it could be in destination. So this, you can combine it both, host and service. This could be quite useful, like I mean, if somebody is complaining you that VPN is not working, or a user is not able to access certain the services, the very first thing you should be able to do that is run this command, and you will be able to see whether the packet is actually reaching the firewall or not. I mean, see, all of you, so you have to understand that, see, whenever you are troubleshooting any issues, which I have seen in my experience, you cannot just simply come to the conclusion that firewall is blocking the packet, or firewall is doing some mischievous things with the packet. The very first question, generally, if you are a technical guy or a person who likes troubleshooting, the very basic question you have to ask yourself is whether the packet is reaching the checkpoint or not. If the packet is not reaching, if you don't see the packet in TCP dump, the packet is not reaching the firewall, obviously there is no point in troubleshooting checkpoint further. Right? I am sure you all of you agree on that. If packet is not reaching, absolutely go back and tell no, packet is not reaching. It could be a routing issue, it could be another firewall which is dropping the packet, it could be anything else. So if you run this command, if packet is not coming, that's it. You say I will not troubleshoot firewall further. Okay, there are very, very special cases where yes, this can get little tricky, which I will just suggest in coming slides, where exactly, even if the packet is coming and something is not working, so where you have to be careful. Okay, but this could be 99% of the time. If you run this command and packet is not reaching, it's not a checkpoint problem. or any device for that matter. Packet is not reaching itself. Now, so far we have discussed about the port part. So port is basically a service, HTTP, HTTPS, SSH, Telnet. But sometimes you just want to capture all UDP packets, all TCP packets. So even that can be clubbed together. You just type, same command. I'm just adding all these commands on the top slide. So whatever you have seen in the earlier slide, I'm just adding few of the features. So what I'm saying is I just type the protocol name. So it could be UDP, it could be TCP, it could be ICMP, you can type ARP, ESP. Okay. By the way, do you know what is the ESP packet? Where it is used? Can you just quickly send me in the chat? Just mention in chat. Okay, Anthony is correct. Okay, Harmesh is correct. Almost everyone is giving the correct answer. So ESP, the moment you see ESP packet, yeah, it's a VPN packet, yes. So when you are troubleshooting, suppose there is a site-to-site VPN, right? And tunnel is up, everybody is telling. The command which you are going to run is, in this case, here, host would be the IP address of your remote VPN gateway, okay? And here you will put ESP, if it is site-to-site VPN. All of you understand? So that way you are telling that any packet or encrypted packet which is coming from the remote site-to-site VPN, it will have the external IP address of the remote gateway. And then it has to, if the packet is encrypted, it will be ESP. If it is not encrypted, it is not ESP. If you don't see any ESP packet, that means the remote gateway is not encrypting the packet and sending it to you. Okay, here itself you will be able to do that. You don't have to go to that VPN troubleshooting on configuration part and stuff like that. If you don't see ESP packet here, that means the VPN tunnel itself has not been established, and you have to troubleshoot on the IPsec phase 1 and phase 2 configuration on both sides. Okay, without doing some randomly testing here and there. Now you learned about how to capture a specific packet, but there are times where you want to negate. You want to say, okay, I want to capture everything except this particular port or this particular host, right? Apart from that particular host or protocol, I want to capture everything else. At that point of time, you will use the word called NOT not. So if you put this NOT behind this filter, it will capture all the packet which is not. So for example, like in this slide, I'm saying not ICMP. So any packet which is not ICMP and it is coming from this host 10, 11, 12 and 22, I am capturing the 5 packets. So TCPDUMP I for interface on the ETH3 interface in my lab. So can you tell me in the chat what is ETH3 as per my lab? Is it internal, external or DMZ or whatever? What is ETH3? Sometimes I have seen like a few people just type wrong interface. So if you have to capture a packet or internal interface of the firewall because client is complaining that they are not able to access something, the very first place, okay, let me give you a question. So there is an internal user who says I'm not able to access, some SAP server, correct? And he will give you the IP address and the port number of that SAP server. And your firewall is having 3 interfaces, internal, external and DMZ. And that SAP server is posted on, hosted on DMZ. So which interface you will run the TCP dump? You will run it on internal or DMZ or external? First, I'm asking where you will start first. Okay, this is interesting. Now we have 50-50. Like now a lot of people are confused. As I told you, right? This is important. So let me see. Yeah, keep coming. Keep sending your answers. So my question was, if internal user is complaining that he's not able to access the machine which is hosted on DMZ and you have to run a TCP dump, which interface you will select first? From where you will start? So Mitesh is given a correct answer. Good. Kiran has given a correct answer. So answer is internal. So first we'll start. Yeah, Deepak is correct. You'll start with internal. See, internal user is complaining. So first of all, you have to check whether the internal interface of a checkpoint is receiving the packet. If the internal interface is not receiving, what is the point of checking on DMZ? I hope you you get my point, like what I'm trying to say. So the first interface you will select is internal, if the internal user is complaining. Similarly, if an internet user, somebody traveling and he says, okay, I'm not able to access your website from internet, at that point of time, you'll start with external first. So whether the packet is reaching your, the external interface of a checkpoint or not. Okay, Anjana is correct, Jignesh is correct, Vivek is correct. Yeah, so internal is the correct answer. Few people have suggested, DMZ, which is not right. Good. Okay. Okay, so far we have run all the commands using the keyword host. But the interesting thing is sometimes you want to just capture for a specific direction. You want to specifically say, no, I want to capture a packet where the destination is the specific IP address. I don't care whether it is a host or not. So at that point of time, instead of host, you just type DST. Okay, just type DST and give the IP address. So if you look at this command output here, so wherever the destination IP address is, so this is interesting. So this is your source and this is your destination. So I'm running a command where it says the destination IP should be 8888. So this is how the packet will look like. There will be a symmetry. Unlike the earlier command. If you look at the earlier command, see here, there is no symmetry. Host is, this IP has to be either in source, correct? This is in destination here, and this is on source. Okay, here it's also in destination. Here it is in source. So when you type source, you can type SRC for source, DST as destination. Okay, so you can capture a specific packet if you want to capture from a particular host, coming for a particular direction. Now whatever we are learning, now we are building up more and more complex. Okay, so I'll show you that yes, whatever we are discussing is not the basic command. We will reach to a level where I'm not sure how comfortable we are TCPDUMP. I'm sure by the time we'll finish the slide, you will be amazed that this much of information we will be able to capture it. Okay, we have still not reached the midway. This is not the peak we are talking about in TCPDUMP. Okay, so Naresh is saying, what is the meaning in TCPDUMP? Who has? So basically it's an ARP packet, Naresh. ARP packet, if it is received on the interface. Okay, so it will be showed here. So basically, can you see here? It's an ARP, Naresh. Okay, good. So this you have seen. Now let's make it more complex. So what we have done here is, what we are telling is, now the destination is particular IP address or destination is this. So X and Y and port is 443. What we are asking here is, if the port is HTTPS, which all machines are going to this IP address as a destination or this IP address. You understand? So either one, if it is going to come up, it will show you in your result. So this could be sometimes interesting because a particular host name is mapped to 2-3 IP addresses. You can always type this command and it will help you to, rather than running multiple putty sessions and running one by one for each an IP address, you can directly club all this together and you should be able to get the output directly in a single line. Okay, so it could be DST or SRC as I told you, right? So it could be any way. You can mix and match. So you can say if destination is this IP or the source is this IP and protocol is 443 or not protocol is 443, anything is fine. Now let's move to the next slide. What I'm going to do, see, I want to finish the slides first because I will be running all these commands in front of you in the lab also. So whatever I have told you, I will run, all these commands to show you, yes, in live also. It's not a, the copy paste. Basically, it's my lab only. So whatever I'm displaying, it's a real command on the Gaia operating system. Okay. I want to spend some time on the lab as well, rather than showing you the, just the commands. The most important, which I have realized from the TAC or technical troubleshooting perspective is one of the most important filter which you should use is it's -E, which I keep recommending many people. Why it is important? Because the moment you will start using E, it will start capturing the MAC addresses. Okay, so this is the source MAC address. This is the destination MAC address. This is the source IP address. This is the destination IP address. Actually, it is hidden here somewhere here. Okay, so this is so sometimes it is necessary to find out from which IP address it is coming. Good. Okay, so this is very important with E. So you have to keep on mapping it, right? From which MAC addresses coming. Okay, by the way, let's have a quick question. So if you have these MAC addresses, what are these MAC addresses? This MAC address, I am running this command on ETH3. Okay, I'm running this command on ETH3 and I have these MAC addresses. What are these MAC addresses? If I'm running a command on ETH3 on CheckPoint, what is the source MAC address and what is the destination MAC address you should expect. You understand the question? You have the topology diagram, you can pick it up. The question is, what are these MAC addresses? If I am running the command on TCPDUMP, what is this MAC address belongs to? To which interface? So which machine? Source MAC address and destination MAC address. Source MAC is the PC and destination is the ISP router MAC. Okay. Why don't you guys just open up the topology diagram and tell me, like, what is this MAC address? F8A3 is belongs to which interface or which device? Yes, Mitesh is correct. Good. Let's see, some people are still confused. Open up your topology diagram, you should be able to get the answer. It's not that complicated. Open up the diagram, topology diagram, you tell me what is this FA8A3, what is this MAC address? It belongs to which device? Ideally, the ETH3's MAC address will be your source MAC address. When the source IP address need not have to be, it could be any source IP address, it don't have to be. So basically, if you understand the OSI model, let me draw this diagram, right? So if you have an OSI model, right? Yeah, I'm sorry for my poor diagram, but you know, so if you have L2 here, right? This is L3. So whenever you are capturing any packet, so all of you should know that L2 information will keep changing with every hop. It will keep on changing it. Okay, L3, which is the IP related details, it could be any source and it could be any destination, but the L2 details has to be the nearest or the adjacent devices. Okay, so here what we're talking about, this is the MAC address of the ETH3 interface. Yeah, everybody will get the slide. Okay, but once we finish the class, I'll just share the slide through the Dropbox, and the destination MAC address will be the next immediate L3 device on the ETH3 side. If it is the destination server itself, so it could be the MAC address of the destination server. If the server is on the internet, then the MAC address will be the L3 device on the external side. You don't have to look at the IP addresses of source and destination IP address. So MAC, you have to match it. So packet is leaving the correct interface and it is exactly going to the right L3 device. So if the MAC address is not correct, so that means you know that CheckPoint is sending to a different gateway. Correct. So this will help you to make sure that yes, you are sending to the right gateway. So here, like now it's got a little interesting. So whatever we have learned, whatever I have told you, and this is where the interesting thing comes. Once you start working with the CheckPoint firewalls. See, all of you, I'm guessing that all of you have worked on CheckPoint. So there is a concept called SecureXL, and if SecureXL is on, basically it's an acceleration technique. So if SecureXL is on, sometimes you will not get the data which you are which you may expect, right? So here I am just capturing the packet on ETH0, which is my internal interface, right? Can you tell me what is this MAC address E736 in the chat? Can you quickly tell me what is this MAC? ETH0's MAC address, because I am capturing the packet on ETH0. So absolutely correct. So source has to be my MAC address. If I am sending the packet, return wise, it would be on the other side. And what is the destination MAC address? Like F5, F1, what is this? On ETH0. So basically I am capturing the packet on the internal side. What is this? F5, F1? Open up the topology diagram. Okay, some people are still confused. Open up the diagram, topology diagram. Tell me. E736, let me open up for you guys. So as you notice that this is a little confusing. Because on ETS2, whatever we have discussed, that ETS0, whenever I am capturing, the destination MAC address has to be ETS0 if I am receiving the packet, because I'm just receiving it on my side, right? And if I am sending packet to the other side, it will be on the source side. But this is not happening. On the same packet for a particular host, you can see here, look at the MAC address is getting jumbled up. So sometimes you see some MAC addresses, and another thing is like another MAC address. Sometimes you will see directly the MAC address of the XP machine and then the web server. What is the MAC address of web server? Open up the topology diagram. It is F5 F1. Okay. So, and look here, the funny part. So ETH0 is internal interface, but I am getting a MAC address of the destination server. Ideally, I should get this output in ETH3. Why this is happening? Because there is a SecureXL enabled. So packets are getting accelerated, and some of the packets which are getting accelerated, you will not be able to capture in TCPDUMP. So it can be a little confusing at that point of time. So why this is important is, if you are running SecureXL, you have to be aware of this particular, the setting, that you may not be able to capture the MAC address as per your needs. Sometimes the packet will also not be there. So that is the reason, if you have worked with that, most of the time they tell that disable the SecureXL and then collect the logs. So this was an interesting point for you. I hope you learned something new. Now again the same command, but I have disabled SecureXL. So as you can see here, exactly the same. So if I see the source MAC, destination MAC, for the reverse packet, this will become the source MAC, and the MAC address which was source earlier, now it has become the destination. So this pattern you will only notice when you have SecureXL disabled. Oh, I think I pressed the pause button. Is it clear now? SecureXL off slide. I am on the slide number 18, SecureXL off. Okay. Okay, good. I'm sorry about that. I think I pressed pause button by mistake. So you have clicked on the off button. What I'm telling is, if you switch off the SecureXL, at that point of time, you will be able to get the expected MAC address details. So if you are running on ETS0, this command, the source MAC address will be your ETS0, destination will be for the next L3 device or the server, if it is the immediate machine is server, and when the reverse packet is coming, this MAC address will be reversed. But when it was SecureXL was on, you will see this all random MAC addresses. F5, F1 is basically the destination server, and you are getting this on ETH0. So this you have to be careful. So you should, disable the SecureXL when you want to, troubleshoot, but don't disable it if your machine is already running on high CPU utilization. Okay, now the important command again. So see, most of you are working on ClusterXL, right? So one of the command which I have found out while troubleshooting CheckPoint is, by mistake, some customers, what they will do is they will plug few cables from the, which are part of the cluster into the same switch or in the same VLAN. So if you look at the ClusterXL admin guide or, the recommended settings, you are not supposed to, put two cables from two different interfaces which are in ClusterXL into the same VLAN. If you do that, it will create a problem. Your cluster will be very, very unstable, and you do not know what exactly, you will not be able to know what exactly is going on wrong. So the best way to run this command or to capture is just run this command. Type the host as 0000. That's it. Because the ClusterXL packet, like CCP packet, these are all the part of your advanced troubleshooting stuff, like how CCD packets work and like my UDP which port and stuff like that. So, but for this class, it is important for you to understand that the CCP packet sends with the source IP address as 000, and it on the port of UDP 81116. So if you are running a command on ETH3, the IP address part, this portion should be from ETH3 network only. You understand? Open the topology diagram and then see what is the IP address of ETH3. So some packets you'll be able to see like that. So ideally you should The idea is if you see suppose 10, 11, 12 and also you are able to see 192, 168, 223. So that means two cables have been connected to the same VLAN and your cluster will never be stable and you do not know when exactly it is going to go down. So the way to troubleshoot ClusterXL, the starting point should be like this. You have to make sure then none of the interfaces which are participating in ClusterXL are overlapping via common VLAN, so that CCP packet should not flood from one network to another because it's a multicast packet. Okay, so this is the best way to run the command. So if you are typing ETH3, the IP address should be from the ETH3. If you see more or different, and you should not, first of all, you should only see one network. That's it. If you are seeing more than one, there is something wrong. So you have to make sure that you are fixing the layer 2 settings on your device. Okay, good. Is it clear so far? So you guys are, can we have a quick shout? You guys are learning something new, or like you guys are aware of all these things, or 80% you are aware of, something like that. Can you have a quick feedback? Okay, so it's a mix of that. Yeah, obviously, like you must have worked TCPDUMP command, I'm sure, like no, and if you have not done that, there is something wrong. Okay, now let's move on to more complex commands. So this does not stop here. So I just included ClusterXL and SecureXL in between because yeah, we are talking about this class is about checkpoint. So these two are only relevant when you are working with the checkpoint firewalls. Okay. Okay. Now look here. For this, I don't have a screenshot because these are little more complicated, and for me to create in the lab, it was difficult. So you can run the same command, but I have already discussed earlier that you can capture the ESP packet. ESP, if you see, this could be your remote VPN gateway and this could be ESP. So if you see the packets coming to your external interface, you know that yes, packets are getting encrypted from the other side and you are seeing on this side. If you want to capture IKE packet, you can select UDP and you can select the port number 5000. So this is required when you are initiating the VPN. So ESP will come into picture only when the phase 1 and phase 2 is successful. So you should always start with this command first, capturing the IKE. I am assuming that you are starting the VPN tunnel from the scratch. You reboot one of the device, run this command on the one side, and then you should be able to see that yes, whether the IKE packet is coming or not. So if they are coming and you don't see ESP packet, that clearly means that there is a handshake issue on the IKE phase 1 or phase 2. But if this phase is okay and you start seeing ESP, that means packets are getting encrypted and it's coming to your device. So most probably it could be a routing issue. Or maybe you do not have a firewall rule. So this is one thing which you will be able to help. Okay, so another portion is when you're running the TCPDUMP command, you can type this minus, VV for verbose. So it will give you on the command line itself much more detail, like type of service, packet size, and much more information. If you are good into reading the header level of information, so this is good for you. If you knew how to read the header of each and every packet, so this you will be able to get some more information if you just add these two additional filters. Some more additional commands. By default, when you run TCPDUMP, this is very, very important. By default, when you run, you only get 68 bytes captured. So primarily, these 68 bytes are the header bytes. So you do not know what is inside the data portion of the header. Okay, by default, this is a setting. So what I mean is, if we try to capture this packets using TCPDUMP, and if there is a clear text traffic, you will not be able to see the content of the data, like username and password and all those stuff you will not be able to see. But if you type with this filter minus S0, so it will capture the full capture packet. So you have to be careful with this. To run this and capture the packet and take it outside, you will be able to see each and everything which is in clear text. If it is not encrypted, you will be able to see inside it. So here I am capturing 100 bytes in each packet. So if the packet is like 1500, I'm just capturing header plus a couple of extra, like maybe 32 bytes extra on that. Okay. Now again, this is another important part. So once you are capturing the packet, everything will be on your console, right? And it can go so fast, then you will not be able to read or understand anything out of it. So what you have to do is, ideally, like on normal circumstances, you have to save it. So there are two ways of saving the data. You have to capture the data, right? So that you can check it later on. The first method is saving into the text format. So you can do like this. So you can just put this greater than sign and then give a folder name. I generally recommend or highly recommend to share like or store all the log files into /var/log, because generally I have seen like 50% of the people, they just run the command on the default folder. Primarily it's a home folder. Okay, don't do that. Okay, always store all your files into a folder or a partition which is having the maximum free size. So var log is basically collecting all kind of logs, right? So you type this. So if you type greater than, all the packets what you are capturing is stored in the text format, just like it displayed earlier in the previous slide. That's the way you will be able to capture it. However, sometimes you want to capture the packet so that you can read it in Wireshark. So this is important. So two things you have to notice here. This is important. Capture.cap, you have to give a file extension, a cap format, so that you can be able to open in Wireshark, and -w, -w, for writing the packet into the binary format. Some more additional commands. So this is the additional command. I will keep on adding more and more stuff, right? Now, so far we have learned only about capturing the network, the IP address of the host part. Now, the interesting part is you should be able to capture even on the network side. So sometimes it is required, you want to capture packet for the entire network. So you can give a subnet mask 16 on particular DS3. So any machine which is falling under this subnet, you'll be able to capture it. And you can give just like normal net. So it could be either in source or destination, or you can specify with TST. So only for the destination network you will be able to capture it. Interesting part, one more thing. So you will be able to capture just by typing broadcast and multicast. Sometimes you just want to capture it, how much multicast I am able to see in the network. So just type the interface name and any broadcast, any multicast. Yes, so Sunil is asking, can we use a source? Yes, you should be able to use net, source, net, or destination net. So it could be anything. There's a combination of these two words. Net basically means a network. It could be source, it could be destination. If you don't specify anything, basically it will pick up source or destination both. Now, port range, another important command. So port range, so this is another important one. Sometimes, like especially working with voice over IP protocols, because they don't, generally work on a single port, and they are, or some other application which is quite complex. So you should be able to put this port range word and just give a range. So any packet which is having these many ports assigned, this could be, see, I have not mentioned TCP or UDP, so it could be TCP or UDP both. If it is able to fall under this filter, you will be able to see the packets. Yeah, Kiran, you should be able to use for source and destination both. This is another important part. Now, I think I'm not sure if you guys are aware of this, up to this level or not. If you know, it's very good. Then you are already up to the mark. So now, see here what I'm trying to do. Now I have captured a packet 13. This is little like getting tricky here and a little complicated here. What I'm trying to do, can anybody tell what I'm doing here? What is this? Can anyone? What I'm trying to do here? Let's see if anyone is able to answer this. Okay, but a good try. What I will do is I will show you why it is 13. All of you are able to see my screen? Desktop. I will just open one browser. Google. Yeah, very good. So just type TCP header. Click any one of these maybe. Okay, so why 13? Why it is 13? Because if you look at the number of bytes here, like 0 to 8 is 1, 8 to 16 is 2, 3 and 4. So you start with 4 here, 8, then 12, 13, and this is 14. Till reserved, you have actually crossed 14 bytes. And since you are starting with 0, it should be this particular area where the flags are inserted. This particular byte will be 13th byte. You understand what I'm telling? This is 13th byte in TCP header. So 12, 13, 14. This is the 13th byte. So in this byte, I am doing an AND operation. Okay, I am doing an AND operation with number 2. How do you represent 2 in binary? It is 1 and 0. Okay, so 13 is because starts with 0. Okay, so 13 is basically means 14. Deepak. So number 13 is basically means 14 because start with 0. So and 2 represent like 1 0. So look carefully. What is 1? So see here, this is a sync packet 1 and this is 0. So what it says is when you do AND operation and if this bit is 1 sync, which is 1 0, so that means it's a sync packet. Okay, so 2 is not equal to 0, not means it is 1. So if it is 1, obviously it's a sync packet. So you want to capture only the sync packet, whether it is coming from one firewall to another or not. Similarly, you can play around with this number 2 to capture maybe a FIN packet or acknowledgement only. So for acknowledgement, what will be the number? Can anybody tell me? For ACK, if I want to capture only the acknowledgement packets, what will be the decimal number I'll put? Instead of 2, what I'll do? So basically what I have to do is I have to type this 1 0 0 0 0 in binary. So how much is value in decimal? 16. Yes, that's true. Okay, so this is how you should be able to play around with this command, and you will be able to know, okay, specific, like if you want to capture only the FIN packets or somebody is sending a reset packet, especially like while working with the servers, you realize that many of the servers will keep on sending reset packet, and you just want to capture it how fast they are sending the reset or FIN packet. You just play around with this number and you will be able to capture the specific packet. Now look at this command. I will explain you here, but when I'm running the the commands live, maybe we can start with this command itself. So what I'm doing here, can anybody tell? So what I'm doing is okay, by the T means timestamp. I don't want timestamp. Like whenever you type a TCP dump, the first the entry is always a time. Look here, the time part, right? I don't want that. You just put T. I'm capturing the packet on LAN 1. Okay is again a Linux command, okay, to filter the information. What I'm trying to do is -F is a filter, dot, based on dot I'm trying to collect, and I'm collecting $1, $2, $3, $4, 4 numbers which are separated by 3 dots. So basically I'm capturing an IP address. Okay? So this is a separator. So if you look at the command, let's go back. It starts here, right? So this is 1.2.3.4. Correct? You'll be able to get the IP address of a particular machine. So this is how it should be. Now you capture the packet, only the IP addresses, then you type a sort command. So you want to sort that into, by default it will do in ascending order, means the smaller IP address will be on the top, and the IP address which is the the high in number will be at the bottom. Then you type a command unique C. C means count. What it will do is it will, whatever the unique IP addresses are there in the list, it will add, or basically it will group, and then the first column it will add as a count. So if you have 10.10.10.10, one IP, one more time 10.10.10, one more time 10.10.10. So after running unique -C, the output will be 3 space 10.10.10. That means 3 times 10 has come. Now you can type sort again, and this time you do in the reverse order, means the IP address which is having the highest count will be on the top. And then you can then filter it more, saying that the count number is more than 10. So why this command is important is because here you will be able to filter a machine which is generating huge amount of traffic. Just imagine if somebody asks you, okay, in last 10 minutes or at this point of time, which machine is generating the highest amount of traffic? This is the command you will learn. Instead of 200, you will put maybe 20,000 packets, because 200 is very less. And then instead of 10, you put 100. So any machine which is generating more than 100 of packets will only be displayed to you in descending order. So the first IP address what you are going to get will be the one which is generating huge amount of traffic in your network. Just single command, and it is giving you exactly what you are looking for, rather than going through the tracker and trying to calculate all by yourself. Does it help? Okay, the final tips. I will show you all this command in the meantime when you are asking the question, so that you all have hands-on also, to you will have proper control what exactly we are trying to discuss, because these things will not be available anyways at one place, especially from the checkpoint perspective, which I already told you, not even troubleshooting, nobody cares about this command. So don't run this command when the CPU utilization is more than 70%. It's very, very important. Note that. If you do that, it is your risk. If you lose your job, don't blame me. Okay. Okay, by the way, this was a joke. So because I have seen personally in my experience, few networks who are, if you just run TCP dump normally, even with the filter of, I think this is distracting Tamil Selvan, I don't know. Yeah, can you switch off your video, Tamil? If you don't mind, yeah, thanks. So if you run even for few minutes, you know how much data we have seen. We have seen few GBs. Like I have seen 5 GB of data getting generated in 1 or 2 minutes for few customers. So you have to be very, very careful how exactly you're trying to do that. Okay. Important thing is next, you should always make sure that you transfer the file outside the gateway. Never ever keep any of your troubleshooting or captured packet on gateway. That doesn't make absolutely any sense. Transfer the file immediately and delete from the gateway. Very well. So happy troubleshooting. Enjoy.